Hello everyone, I am going to start a new topics which is related to design of welded structure. In this topic, I will discuss on design of welded joints subjected to combined types of loads. Before going to discuss or before going to start these new topics, first of all, we need to know some fundamental terminologies or you can say some fundamental factors which are highly essential for the design of welded structure. So, this is the content of today's lecture. Here I will cover the following topics. First of all, I will discuss about the strength of welded joints. Then I will discuss about the principle of sound welding design. Then I will discuss also about allowable stress and factor of safety. After that I will discuss first the welded joint subjected to torsional moment, then I will discuss welded joint subjected to bending moment. Then due to combination of these two different types of loading, what should be the design procedure for welded joint subjected to both torsional moments and bending moment, that means due to combined loading. So, first of all we should know what is strength of welded joint. So, generally the permissible stresses for welded joint in certain structures such as you see unfired pressure vessel, framework of building, then ship or bridges, generally these are the structures which are covered by some national and international codes. So, while designing such a structure generally or the part of that structure, it is compulsory, that means you can say to use the values of permissible stresses which is given in those standard, that means which is given in the relevant standard that we need to follow. So, here I have used a term such as unfired pressure vessel. What does it mean? Unfired pressure vessel means it is a, you can say, which are not exposed to any form of combustion, this you can say. This unfired means it is not subjected to any form of combustion such as pressurized cylinder or it can be vacuum cylinder also, which is not subjected to any types of what it is called combustion effect, that you can say. Whereas fired pressure vessel also are there, which is generally used in case of water tubes, boilers. It is also used in the case of you can say fire tube. So, those are generally you can say fired pressure vessel. So, they are generally for those types of structure there are some national and international codes, this you should keep it in mind. However, you see there are a number of welded machine components are there which do not come under those national and international you can say standard or national or international codes. Such component can be divided or you can say classified into two groups. So, in one groups we can say where the strength of generally weld is more than the strength of part joined together, that means you can say the strength of weld zone is more than the strength of parent material. In second category, generally where the strength of the weld is less than the strength of the what it is called connected parts. What does it means? Let us consider this two plate which we have joined here by welding. So, this is actually weld. So, in first category I told you the strength is more in this weld zone, whereas in second category the strength is more in this part connected, that means strength of the connected part, that means this parent material you can say, that means this is generally part, one part, this is one part, this is another part, okay, this you can say. So, in second category generally we consider this part strength is more than weld. So, in the first category where the strength, first category means this is first category and this is second category. First category means where the strength is more in weld, generally here the failure is occur in the part, that is I have written. While In the second category, always you should keep it in mind, it will fail definitely in weld deposit, because in second category the part strength is more than the weld. That is why in second category the failure will be occurred in weld. Now, generally when this first category we can achieve, for that generally we need to have some condition. That means, the strength of weld deposit is more than the strength of connected part under some few condition is there, when it will be more. For that we need to follow some condition. The first condition is generally the component, or you can say this part, this is also you can call as component. This component should have a what it is called carbon content less than 0.3%. This you can say carbon percent should be less than 0.3%, this is one condition, and that is generally called as mild steel. And whatever the electrode material we will use for welding, that electrode should have a content. So, electrode, let it be consumable electrode. So, this electrode material is contain a carbon percentage which should be around 0.15%. What I am telling, understand? This is second condition. And another condition is, let the welding is done by using SMAW welding process. SMAW means shielded manual metal arc welding, shielded metal arc welding process, or you can see you can called as stick welding process also. And the electrode also should generally should coated with a standard coating material. This coating generally once it is burned, then it creates some gases which generally protect the weld pool from atmospheric condition, or you can say atmospheric contamination. From atmospheric contamination generally these gases protect the weld pool, which act as a shielding medium. This you should keep it in mind. So, this electrode here generally you can say for stick welding or SMAW welding process, generally the electrode how it look like, little bit I am just showing. It has a core metal, you can say core metal. Over this generally there is a, you can say there is a cover, over this there is a cover or coated material. This is generally called coating. So, this is the condition I have told you, the electrode should be coated, and it is here generally this SMAW, this is a consumable types of electrode. That means, why it is called consumable types of electrode, means this electrode carrying current as well as due to heating it is melt and it is deposited. That is why as it is consuming during welding process, that is why it is called consumable electrode. This you should keep it in mind. Okay. So, once we follow these three condition, then what happens, you can say the weld strength is more than, is you can say greater than the component strength, or whatever the part we are connected, that part strength, you can say parts strength. So, in this case the failure will occur where? Failure will occur in part. This you should keep it in mind. Failure will be in part. This is one category I am just going to discuss, in parts. Now, for these three condition, generally there is some standard, you can say there is a standard table for permissible, you can say stresses. This table I am showing in table number 1, you can see. So, for this types of three condition where the weld strength is more than the part to be joined, for that generally there is a standard table where generally the permissible stress is recommended by a researcher whose name is Jennings. So, his name is C.H. Jennings, I have just written here, this table is recommended. So, this table generally for those types of condition of welded joint, we need to follow this permissible stress. So, first of all we should know what is permissible stress. So, you know that permissible stress means is that stress you can say which is generally used in design. This permissible stress generally used in design to determine the dimension of the component, this you can say. So, what is the definition of generally permissible stress, or this permissible stress also have a name, you can consider as allowable stress also. So, it is generally used to you can say design or to determine the dimension of a component. Now, what is the range of this permissible stress, how it look like, little bit I am just showing. Let us consider there is a stress strain curve, let this is our stress and this is our strain. Let us for mildly still the stress strain curve is look like this. So, you can say this is generally known as yield stress, sigma yield, upper yield stress. This stress level is known as you can say whatever the stress is there, this stress is known as sigma ultimate stress you can say. So, as this is a yield stress means you know all of you are very well familiar, after that generally plastic strain start or plastic deformation start. Ultimate stress is the maximum stress of this stress strain curve, that is also known to you. That is why this is instead of calling as stress you can call this yield strength, or you can say ultimate strength of the material. Generally the permissible stress is far below this maximum or you can say yield stress or maximum ultimate stress, this you can say it is generally far below and it is generally within a range of elastic range. So, this is generally called as permissible stress, this is also called as working stress or allowable stress. So, generally the component which is designed during welding, we generally consider the stress level should not exceed this what it is called permissible stress or allowable stress. Based on this stress level, we generally design the detailed dimension of the structural component, this you need to know. So, based on this you can say permissible stress or allowable stress, we can define some factors of safety. So, above this generally you can say allowable stress level, these are generally called you can say reserve strength or you can say reserve stress, which is unused stress during your whatever application of that component. That also I will discuss in subsequent slide in details. So, you see for this following three condition a researcher whose name is C.H. Jennings, who generally proposed or recommended some permissible stress value both for static loading case as well as reverse loading case. In a static loading case generally you know for butt welding he told for during tension for those types of welded joint with above 3 condition or above 3 composition you can say, during tensile case in a static load the permissible stress should be 110 within this range. Then compressive stress should be during compressive case it is little bit higher side, that is why we have considered is 125 Newton per millimeter square. For butt welding in case of shear it is further less than the both tensile and compression case, it is 70 you can say MPa or Newton per millimeter square. And in case of fillet weld, always you should keep it in mind, in case of fillet weld there is occur generally a shearing types of failure. That is why whatever the permissible stress for static and what it is called reverse types of loading it is given, this is generally due to shear. That is why this is also called permissible, you can say permissible shear stress in case of fillet weld. This is called permissible shear stress or permissible allowable stress, this you should keep it in mind, both are same. Now, in case of static loading you can say here with time generally load does not vary, that is why what happens here the permissible stress is higher than this reverse types of loading, where generally this is a, you can say, repetitive types of loading, which is a dynamic phenomena also, you can say. That is why for this case generally permissible stress is much lesser than a static loading case. This you should this also I will discuss in details in subsequent lecture. Generally for you can say reverse types of loading, for butt welding in tension case it is 55 MPa, because Newton per millimeter square also is equal to 1 MPa, you can say megapascal, this you should keep it in mind. So, in case of compression case we consider is permissible stress is 55 MPa, in case of shear it is less than those tension and compression case, it is 35, whereas in flat here always generally the failure is occur due to shear in throat area. That is why what happens here, whatever the permissible stress is given, it is generally permissible, you can say permissible P shear stress, here I am writing, this is also permissible shear stress, this you should keep it in mind. So, this is generally this table is for the above three condition, but some other components are there which generally are not follow those types of material combination or those three condition. For those types of materials such as for high carbon steel, in this high carbon steel here generally carbon percentage is varying more than 6%, you can say, it is varying from more than 6% to around 2%. Some book it is written 0.6% to 1.25% also. Okay. Generally 0.6 to 1.2%, this 25% is weldable, it is you can weld those types of, you can say, high carbon steel. These types of high carbon steel or some alloy steel also there, where generally you can say weld deposit is weaker than the strength of the connected component, this you should keep it in mind. So, for high carbon steel the you can say weld deposit is weaker, this is second categories of what it is called welded joint. Okay. Here welded joint is weaker. For this case generally we use some other types of you can say condition for determining the permissible or allowable stress. So, in this case the property of weld deposit whichever we are using, that property generally we consider such as tensile strength or yield strength generally are considered as a criteria for determining the permissible stress. So, for finding out this permissible stress, here one thing you should keep it in mind, generally whatever the weld deposit or electrode we are using, based on this electrode property, you can say electrode property means electrode yield strength or ultimate strength, we decide the permissible stress, this you should keep it in mind. For some example I am showing here, the mechanical property of two electrodes here I am showing. It is generally in this case its tensile strength for the first category which is showing E XXX-41, it has a yield strength is varying from 410 to 510 MPa, whereas second category EXXX-51, here generally tensile strength varying from 510 to 610, and yield strength for first category is 330 MPa, because this is also MPa, and for second category is 360 MPa. So, this is the generally what yield strength, and you can say this is the ultimate strength of this types of electrode for this two electrode. For those types of weld joint generally we use this tensile property and yield strength properties, material property to determine the permissible stress. So, always you should keep it in mind, here we are not using this tensile strength or yield strength directly as a permissible stress. For those types of cases we need to specify some factor of safety. So, those factor of safety, that means those factor of safety we use to find out this permissible stress like sigma p, or you can say let this is allowable stress sigma a, this should be equal to you can say yield strength divided by those factor of safety. this factor of safety have a value, always you should keep it in mind, it has always a value greater than 1. Okay. This you should keep it. In case of welding, it is little bit higher side, it is varying from 2 to 4. So, for generally for ductile types of material, we use yield stress divided by factor of safety to calculate the permissible or allowable stress, whereas for brittle material, here I am writing, for brittle material generally we use to calculate the permissible stress or allowable stress the ultimate stress, you can say ultimate stress, or you can say ultimate strength, because this is the highest stress of the stress strain curve. That is why instead of calling as stress, it is better to call as strength. This you should keep it in mind, factor of safety. FOS means factor of safety. This is for ductile material. Okay. Now, this whatever the electrode we are using for welding this high carbon steel, this has a well defined standard, well defined specification, you can say, that I will show in subsequent slide. So, here you see I have written generally this electrode, whatever the electrode we use, it is generally designated by a suffix letter followed by 6 digits numeral, and the details can be obtained from those standard. I will show you one example which is based on American Welding Society standard, and next slide itself I will show. Before going to these things, here I just mention what is factor of safety. Factor of safety generally we use. So, due to this high degree of variation in workmanship and inspection, as well as because of the complexity of the stress distribution in welding, and there is some there can be some uncertainties in loading, generally a high factor of safety we used in case of well design case. This you should keep it in mind. So, what is just next slide I am going to show a what is called electrode specification details, like this is a electrode I am showing, which is a electrode for SMAW welding process, that is shielded metal arc welding, or it is also called manual metal arc welding process, or it is also called stick welding process. Okay. This electrode here I have shown, you see it has a inner core is there. This is generally metallic core, which is generally deposited as a weld metal or weld material. Outside this core I have already shown, there is a cover, this is called flux cover, this is called flux cover. This has some ingredient, this depending upon those ingredient, this electrode is categorized. Like in case of SMAW process, there are, you can say 3-4 different categories of these electrodes are there. Then one of the categories is called like you can say rutile types of electrode, cellulosic types of electrode, basic types of electrode, as well as you see metallic types of composition also sometimes used in this flux. So, that is generally called metallic types of covered electrode. Then this flux generally once it burn, then it creates some gases, and it generally create a protective layer of what is called slag. That means, flux once it burn, then this is called generally slag. What is slag? Slag is burnt flux, as well as it is generally take out the impurities, you can say, if there is inside the parent material, it generally remove those impurity, and it float over the surface of the weld deposit, and it generally also protect the weld pool from atmospheric contamination. So, it create gases as well as it create a covered layer, this flux, that's you know very well. Generally these types of electrode, one of the specification here I am showing, like it is based on American Welding Society classification. So, one of the specification here I have shown, you can see, like this first letter is E represent electrode. The after that this first two terms like 80, it is the tensile strength of that electrode in KSI. What is KSI? KSI means kilo pound per square inch. This you can say kilo, KSI means kilo pounds per inch square or square inch. This you should keep it in mind. Now, then this third you see this third numeric digit like 1 here I am representing, this is generally represent the what types of position of welding we can perform by this electrode. Like if it is 1, this 1 represent for all position you can say electrode, that means this electrode we can use in all the position. Positional electrode, what does it, positional welding, what does it means? Means the welding can be done in what it is called downhand direction, it can be done overhead direction, it can be done horizontal direction, it can be done vertical direction also. So, depending upon this position, generally welding electrode also is categorized. All the electrode we cannot use for all positional purpose. That is why once it is 1 means this electrode we can use for you can say all position purpose, means all the 4 position which I have told, all the 4 position purpose we can use. Then this 4th digit you see 8, here it represent the type of coating, whatever the flux coating is there and what types of current we are using, because this types of SMAW welding process also sometimes called what is constant current welding process, or it is also sometimes called drooping types of characteristic welding process also. Now, last 2 digit this B2 represent the chemical composition of the weld metal deposit. This you should, that is one example I am showing what is the different digit represent. So, this also you should know. So, this after electrode E terms, whatever the first 2 terms is there, that represent its you can say tensile strength of that material. This you should keep it in mind. Now, we are going to discuss generally what are the principles of a sound welding design. This we should know before going to discuss about the detailed design process. This first of all we should know. Like the principle of sound welding design contain different aspects you can say. Like you see the first point you can say whatever the material we should use for welding, this material we should choose such a way so that which require the least in welding precaution as well as it should require least skill. So, when we go for designing a structure where the welding will be done, this structural material should have this this following property. That means, it should require you can say least welding precaution as least skill during welding, this you can say, because different types of material have different types of welding condition and different types of difficulties of welding. This you should keep it in mind, because all the material have not same types of difficulties. This you should keep it in mind. Okay. For like whatever mild steel, it is generally little bit easier process to do the welding. Once you go for high carbon steel, it is generally require you can say high level of skill and what happens high precaution also required there to do the welding process, because it is difficult to weld also. Then second principle you can say, at least mentally we should review all the welding process available and applicable to various part of the design on the basis of what thickness, material and its form, how its what should be the shape of that structure and quantity. So, before going to design we should mentally prepared what are the different welding process are available in our company, you can say in our manufacturing department, that we should based on those machine we should design our you can say component. Okay. This you should keep it in mind. The third point is, that means estimate the stress pattern under load, where we should consider the concept of stress concentration. That is I have written, estimate the stress pattern under load with respect to stress concentration. Why? Because during welding what happens, There generally microstructural changes, there can be inclusion, there can be porosity, there can be what it is called some types of other defects also. And that means estimate the stress under load with respect to stress concentration, and examine the design for possibility of losses, because we should examine it also. That means there can be some possibility of losses, I have already told you, because welding there can be different types of defects. So, those possibility also we should consider during designing the welded structure. This you should keep it in mind. Why? Because these losses give rise to stress concentration. This you see, it generally rise the stresses in that location where the losses is there. So, this point you should keep it in mind. Okay. Then the fourth point is, so weld should always be placed in the region where the stress level is lower. So, welding we should decide on those places where the you can say stress level is lower. The fifth point is, welding more than necessary should not be specified. These are all principles of sound weld design. Okay. That means unnecessary welding should not be specified. Then the next point you can say, it should not be done where it offer no benefit. That means where you are getting, that means some benefit, if you will do some welding you will get some benefit, there only you do the welding. Where you are not getting any benefit, you can, if you can do it by some other processes where less cost, less precaution is required, then you use those things. But where you feel that okay, if you will do the welding those location, if you will get some benefit from there, then you offer welding on those location. Where no benefit is there by welding, you need not to specify welding there. Okay. This is also another point you should consider. And the another point is, design should not be demand a consistency of welder's performance. This is another also a very important point. That means during design process you should consider this thing in mind, that okay, the welder always will not perform the welding which is consistent, that means which is highly accurate and it is remains same in every passes. These types of what is called demand should not be there during welding process, because as it is difficult to maintain, because there can be some what happens uncertainty during welding by the welder also. This point also we should keep it in mind during design. That is why some extra factor of safety is required to put, I have already told you. Now, the another point is, design should specify critical weld location also. So, during design of welding structure, we should specify what is the critical zone of that structure, that location also we should specify of that welded structure. That means, it should specify what is the critical weld location, because there we should do our you can say inspection very regularly. That is why what happens, we should specify those critical weld location. Then the last point, that means design should not generate any unnecessary problems in the production department, because your design should be user friendly. That means what happens, whatever the facilities, whatever the existing equipment are there, what happen, based on those things, considering those things in mind, we should design our welded structure. So that what happens, using those facilities we can do the welding very easily, because it should not create problems in production department. This we should keep it in mind, unnecessary problem it should not create. Now, allowable stress and a factor of safety, which already I discussed little bit, here also again I am discussing, because while designing a component it is necessary to provide sufficient reserve strength in case of an accident. Okay. This is generally achieved by taking a suitable factor of safety. So, what is factor of safety? I have defined here, like factor of safety is the failure stress. I have already told you This failure stress generally in case of ductile material is yield strength, in case of brittle material generally this failure stress or failure strength is considered as ultimate stress or ultimate strength divided by its allowable stress, or this allowable stress also called as permissible stress. This you should keep it in mind. This is also you can call as permissible stress. This you should keep it in mind. Okay. Now, then factor of safety also you can define in terms of load also, that is called failure load divided by working load. Okay. Now, here one thing you should keep it in mind, this allowable stress value which is generally used in design to determine the dimension of the component, and these allowable stress generally considered as a stress which is generally which the designer expect that the weld will not be exceeded under normal operating condition. That means, the weld component which is made, generally this structure should not subjected to a stress level above this allowable stress. Generally this designer generally initially consider these things, based on this consideration he generally determine all the dimension of the structure. This you should keep it in mind. Now, why this factor of safety is come into picture? There are a number of factors which are difficult to evaluate accurately in design analysis. So, this factor of then generally the factor of safety ensure against this uncertainty and those unknown condition. This you should keep it in. So, factor of safety, why it is required? Because lot of points are or factors are there which are very difficult to, you can say, predict accurately. For those reasons generally this factor of safety also required to define. Okay. Now, we will go to discuss about design of welded joint subjected to combined stresses, or you can say combined loads also you can say. Actually what happens, a welded structure can subjected to what is called direct, bending, torsional, or you can say shear types of stresses. But what happens, these stresses do not necessarily occur separately, correct. These stresses can act independently, as well as what happens, these stresses can act in a structure combinedly. Due to this combined loading, the weld have therefore to be designed to take into account of a combination of stresses. That means, instead of considering individual effect, we need to consider if a welded joint subjected to combination of different load, then due to the different load what should be our design procedure. So, some of the examples I am going to discuss in this course, you can say. For example, a welded joint in service may be subjected to torsion or direct stress, it can be subjected to bending or direct stress, it can be subjected to shear or bending stress, it can be subjected to shear or torsion stress, it can be subjected to bending or torsion, or it can be subjected to all 3-4 different types of loads also. If it is subjected to all 3-4 different types of loads, then how to design those welded structure, that related things in details I will discuss in this course. One of the examples just I am just showing, like an example, a marine propeller, you know, which may experience direct load, torsion, bending as well as shear simultaneously. This you should keep it in mind. Okay. A propeller which we use to move a ship, generally that propeller can be subjected to different types of combination of load. Like here you see 4 different types of combination of load it can be subjected. So, due to this 4 different loading, if it is subjected, then what should be the design procedure for those types of structure, that will be discussed in this course in details.